Hello everyone. Welcome back to okay. Welcome back again. So today we'll be doing the second lecture for that is elementary shapes in 2D and 3D. And as in we have studied like tracing of the like line segments, like measurements of the line segments. We have done with the different ways. What are the best ways that we can get the answer for it? Then we studied about the perpendicular lines. Then we have studied about the perpendicular bisectors. And in the last class we have studied about what are the closed figures and what are the closed curve, what are the like open curves, right? What are simple curves, what are non-simple curves, right? So this we have already done in the last class. So today we'll be starting with that is the second lecture. Here we'll be learning about the quadrilaterals and its properties. And to be very honest, we teach these properties in the class 6 in itself, but these properties will be again taught in the class 8, and again it will be taught in the class 8th, but generally we don't teach, and again in the 9th, because there is again a one chapter of quadrilateral where we will be doing a lots of proving. So what happens, so once you have understood this topic and have memorized the properties of these quadrilateral at this very stage, so the questions regarding the geometry, which consists of like different types of geometry, and the higher questions will become very easy for you. You can get the answers very fast, and then you don't you can just you will be in a condition that where you can be solving the questions of grade 7 and grade 8 in the class 8 itself because of knowing the property, right? So it's like this. So what you do, you start memorizing the properties and you see these stuffs in your day-to-day life also. So let's begin with it. Okay, so let's get started up. Okay, I forgot, I'm Sakshi Kesharwal and I'm a maths expert in the Ask IITians. So let's get started over here, beta. Yeah. So today we are starting with understanding elementary shapes in 2D and 3D. Here you will be learning the stuffs which will be used, which will be a part of class 7th, 8th, 9th, 10th onwards. But this is again taught in class 8. So once you have understood this topic and memorized these properties, this will definitely will help you in the higher grades also. Okay. Okay, so we'll be doing the topics over here: quadrilaterals, polygons, and the solid shapes, right? These are the like, till now we have been doing everything on the lines and line segments, angles, yes. So we'll be learning more about it. So basically, we have learned about the types of triangles, right? Triangles on the basis of sides, on the basis of angles. So on the basis of the sides, like what is a triangle? Triangle is a three shape. It's a polygon with three sides, right? It's a polygon with three sides, and it consists of three angles. And we have learned about like if the three sides are equal, then when it depends on the side, on the basis of the sides. When all the three sides are equal, then it is said to be what, beta? Equilateral triangle. When the two sides are equal, it is said to be what? Isosceles triangle. When none of the sides are equal, then we say this as a scalene triangle. And when the angles, depending on the basis of the angle, like if all the angles are acute, then we say this as acute angle triangle. If one angle is 90 degrees, then we say this as right angle triangle. If like one angle is an obtuse in the triangle, then we say this is obtuse angle triangle. So this we have done in the last class. So today we'll be starting with what, beta? Quadrilateral. Yes, a quadrilateral is again a polygon, right? It is like if you take any four line segment, it's a polygon only. So we have like just classified two, that's triangle, and then we have classified as a quadrilateral. So if you're going to break the word, that is what is a quad. Quad means what? And lateral. Yeah, so let's break the word. Quad means what? Four. Yeah, and lateral means what, beta? Side. So it is a polygon. Basically it is what? It is polygon with four sides, right? It's just polygon with four sides, right? We can say this. And it has four straight has four sides, right? It has four straight sides like a b b c, you can say. Like it has four angle, that is angle a, angle b, angle c, and angle d, right? And all four interior angles sum up to what? 360 degree. And this thing I have taught you in the like previous lectures, and I think so this much is clear. I don't want to go it furthermore how this become 360 degree. And we have like taught you how many diagonals that it will have. It will have two diagonals. We have also done that. A quadrilateral a quadrilateral have two diagonals, right? It have what, beta? It have two diagonals. Yes, it have two diagonals. And what are the diagonals, beta? That is AC and BD. This we have already done, right? This we have already done in the previous classes. Like that is AC and BD, right? So there are some special types of the quadrilaterals that we see into day-to-day life, and we should know the properties of it very properly, right? So one thing we know that let's talk about something. If you have the parallel lines, as I told you, if these two lines are parallel, the distance between the two lines will be what, beta? Always equal. If you measure the perpendicular distance from here, if you measure the distance between two trains, you have seen like railway tracks, and the wood which has been between the two tracks are always same and the equal or not. So the distance between the two parallel lines are what, beta? Always equal, right? So we say that the distance between, we say perpendicular, I'll say better perpendicular. You can expect that this is a distance. No, distance is always the perpendicular we count, right? So we say that perpendicular distance, right? Perpendicular distance between two parallel lines are equal, right? Are always equal. This thing we know, right? Now coming to the next slide. See over here that let's talk about like quadrilaterals we have already done, right? So I'll give you one question like this. Let's do one question. Okay, so if I give you like this is a question, right? And I said that this angle is 100 degree, right? And this angle is 60 degree, and this angle is 20 degrees. This angle is x, and this angle is 90, then this angle is y, right? Find x plus y, right? So you can see that it is a quadrilateral. See, you can do this question in two ways, right? ABCD is what? A quadrilateral. Quadrilateral, let's go on the one thing. It is denoted by, like if I'll find like this, it is denoted by, yeah, it is written like this. It is written as quadrilateral ABCD. Whether you write for a rectangle, square, rhombus, or whatever, the quadrilateral, general quadrilateral is written with the symbol. And the triangle we write like this. Triangle we write like this. This is for the triangle, and this one is for beta quadrilateral. This is just a symbol that we, instead of writing TRIANGLE, we write this symbol that yes, see, we are talking about a triangle and we are talking about a quadrilateral, right? Okay. So I said that find the value of x and y. So as we have learned, like you can just go with the two methods. Like what are the methods? Like either you can say that in triangle BCD, right? You can see that in triangle BCD, you can say that that is x plus y plus 90 is equals to how much, beta? 180 degree, right? So can I say that if the sum of the one angle, you have to find x plus y. So x plus y will be equals to how much, beta? 90 degrees or not? Yes. This is what method one. This is what method one, right? Now let's talk about method two. What is a method two? Method two is equals to what? You can take that the quadrilateral ABCD, right? Quadrilateral ABCD. So it will be what? Angle A plus angle B plus angle C plus angle D is equals to how much, beta? 360 degrees, right? So we can say that angle A is what? 100, right? Angle B can be written as what? 20 plus x, right? Angle C can be written as what? 60 plus y, right? And angle D can be written as 90 is equals to 360 degrees. So you just start, add it up. So it will be what? 190, 250, 270, right? So 270 plus x plus y is equals to what? 360 degrees. You can do this orally because I think so. The way I'm writing, you're feeling like very uncomfortable. You can just add up all the numbers and subtract it from 360, right? So if you're going to like the sum of the addition will be what? 270 and then subtract from 360. So x plus y is equals to how much, beta? 90 degree. Or it is equals to what? X plus y is equals to what? 360 minus of 270, right? Which is equals to 90 degree. Either you can go like that, right? Now let's coming to what is a parallelogram, right? These are the special types of what is this heading? Special types of quadrilateral, right? Special types of quadrilateral, right? Now see over here, what is a parallelogram? Parallelogram means what? If you take like this and you take this parallel line, right? Yeah. And see, and if you are going to take this, color didn't change. Yeah, color changed. Okay. Yeah. Take this. These two are what beta? Parallel lines, right? So can you see that a quadrilateral is formed? Yes or no? Quadrilateral is formed or not? Quadrilateral form? Yes. This quadrilateral form, and this is called, specifically called, this is called beta what beta? Parallelogram, right? Parallelogram. In short, we write this LL, that is parallel line symbol, and we write GM, that is what parallelogram is. A very big spelling, so it's very difficult for us to write what is a parallelogram. So any quadrilateral, then the opposite sides are parallel. So you see around yourself a lots of parallel figures or not? Yes or no? Can I take this like the scale right now in my hand, that these two sides are what? Parallel to each other, and these two sides are what? Parallel to each other. So this is what a parallelogram. Yes or no? If you take this sheet, like, can you see this? Right. So this is again a what? A parallelogram. Initially, it is what? A parallelogram. And then we have then a specification, and then this become a rectangle. So what is a parallelogram, beta? Okay. First, you write it this. What is the definition? A quadrilateral in which both pairs of opposite sides are parallel is called parallelogram, right? In this given figure, you have this figure, right? So can I say that beta AB is parallel to what beta? DC. Yeah, this is a symbol for parallel, right? Parallel, right? And can I say that AD is parallel to what? BC? Yes or no? So there are some specific property that you should know. What are the properties over here? The properties are this. If this is a parallelogram, I'm writing A, B, C, and D, right? So this side is parallel to this side, and this side is parallel to this side. You will do the every proving of it. So first you should know what are the properties. Right now we ask student to memorize it, but later on we give the proving of everything. Right? We will do the proving, as this will be a part of your curriculum in the class 9th grade, because there will be more of the geometrical concept involved in it. So once you know all the geometrical concept, then it's like it would be easier for give you the proof, right? But you don't know all the geometrical ideas, so like geometrical things over here, so we don't tell you the proof. So what are the properties? If you start memorizing it, we have learned that what is a parallelogram. Parallelogram means what? Opposite sides are what? Parallel. What is the property one? Property one says that opposite sides are equal, right? Opposite sides are equal. Opposite sides are equal, right? Opposite sides are equal. What are the opposite sides are equal? That is AB is equals to DC, and AD is equals to what beta? BC, right? Second property is that opposite angles are equal. Opposite angles are what beta? Equal. Opposite angles are equal means what? Angle A is equals to angle C, and angle B is equals to what? Angle D, right? This angle is equals to this angle, and this angle is equals to this angle, right? Third property is that beta diagonals are not equal. Here the diagonals are not equal. Are not equal. Now let's see, this is the diagonal, right? The diagonal AC, and this is the diagonal BD. They meet each other at point O or not? Yes. So diagonals are not equal. And then the fourth property says that diagonal bisect each other. We have learned the word perpendicular bisector, and we have learned about the bisect also. If I am just drawing a line like this, that it is bisecting means what? It is dividing this line into equal half. And let's talk about this bisect each other means like AB AC line is, and this is like BD line, right? So A is like BD divide AC into two equal parts, and BD divides and AC divides BD into what beta? Two equal parts, right? So we say that diagonals diagonal bisect each other, then we say that AO is equals to OC, and OD is equals to what beta? OB. These are the properties of what beta? Parallelogram, right? Now, let's come into the next figure. What is a square? You see square all around you. Have you seen that the top of the like a Rubik cubes? Yes, that's a square, right? I have like many figures like you see around you. You buy like a notebook or something like that. This is the shape of a square, right? So generally we see square all around. So we see that in a square, can I say that opposite sides are what beta parallel or not? So a square is also a parallelogram. Yes or no? Then you see, as I said, that is what is the second property. Opposite angles are equal. So can I say that this angle is equals to this angle and this angle is equals to this angle? Yes. But this is the most important thing. What is the definition of a parallelogram? The general, we don't go on the property. We just go what is the definition of a parallelogram? Any quadrilateral form in which opposite sides are parallel, then it is a parallelogram. So here the opposite sides are parallel or not. So can I say that it is a parallelogram? Yes or no? Yes, it is a parallelogram, right? So what does we say? We say that is a okay. Okay. So what is a square? Square is a quadrilateral in which opposite sides are what beta in which all sides are equal, right? So what are its properties? Its properties are like this. Properties are like this. So what is a property? It says what all sides are what? Opposites first. It's like this. First I'll write this. Opposite sides. Wait a minute. We say that opposite sides are parallel, right? Right? Second is that all sides are equal, right? All sides are equal. Yeah, all sides are equal means what? AB is equals to what? BC is equals to what? DC is equals to AD, right? All angles, right, means what? All angles are at 90 degree, right? Can I say the fourth part? That is diagonals are what beta? Equal. Diagonals are what beta? Equal, right? And the fourth part is that the diagonals bisect each other at 90 degree, right? So when you're going to draw a diagonal over here, this and this, right? This is like here you see that this is going to meet at O point. This is 90 degree. So if the diagonals are equal, so can I say that beta AO is equals to OB is equals to what beta OC is equals to OD, and can I say that AC is perpendicular to what beta BD or not? Can I say this? Yes or no? Chalo. I'm giving you one question. So as I said, if this is a square, right? This is a square. Now I'm giving you the question. Let's do one question. Question is what? I'm writing this A, B, C, D is a square, right? So question is what? A, B, C, D, quadrilateral A, B, C, D is a square, right? Is a square. And I said find X, right? Find X, right? How you're going to find X. So you should know all the properties very well, right? And I'll give you one more question like this also. No, I won't. I don't want to, because there are many things that you should know about it. So let's go with this. Okay. Let me change my color. So this find X. So as we had seen that beta, that you don't know isosceles triangle property, right? Because in isosceles triangle, that is base angles are equal. Okay, I'll write this as X, right? Find X and X, right? That's okay. So we know that in a square, this is a square, right? So you have to find X. So basically, beta, this angle is how much beta? 90 degrees or not? Yes or no? So can I say that in triangle ADC, Can I say that in triangle ADC, that is x plus 90 degree is equals to how much beta? 180 degrees. So can I say that this is 2x are equal? So can I say that 180 minus 90 will be what? 90, and divide by 2 it will be what beta? 45, and this will be what? 45 or not? Yes or no? So can I say that 2x is equals to what? 180 minus 90. So it is equals to what? 2x is equals to 90. So x is equals to what? 45. This is the mathematical approach, but I'll prefer that if you are like new to it, so try to go mentally. Like if this angle is 90 and the other two angles are equal, so the sum of these three angles will be what beta? 180 degree, like x plus 90 will be 180 degrees. So subtract 90 and you will get what beta? 90, and 90 has been getting divisible by like two parts, right? So this will be 45. So similarly, can you find y and y? Yes. So y will also be equals to what beta? 45 degree. Yes or no? Because this is 90 degree, this will be again what? 45 degree. So this is equals to what beta? 45 degree, and this is equals to what? 90 degree. Coming to a rectangle. What is a rectangle, right? If you see that, again, this is what? A parallelogram. Opposite sides are what? Parallel. Yes or no? Opposite sides are what? Parallel. So what is a rectangle? It says that if one angle of parallelogram is a right angle, then it is called a rectangle, right? Yeah. So we see a rectangle all over place. Can I say that this scale is a what? Rectangle, right? The sheet of the paper is what? A rectangle. The top of your laptop is what? A rectangle. The curtain which you use is what? A rectangle. Generally, the bed sheet which we use in the shape of what? A rectangle. Yes, because we see that all sides, like opposite sides, are equal, right? If you see the window, that is the top of your window, it will be a what? A rectangle only, right? So what is a property? So let's talk about a property. So let me draw this again. Yeah. Yeah, see this. So this is what A, B, C, D, right? So we say that it is a basically a parallelogram in which like one angle is 90 degree. If one angle will become 90 degrees, so all the angles will become what beta? Automatically 90 degree, right? So basically what happened, like over here, what are the properties? If you go start writing the properties, if you write the properties means what? Opposite sides are beta parallel, right? Opposite sides are parallel, right? Second is that beta opposite sides are equal. This side is equals to this side. So see the stroke which I make. Single stroke means what? That these two sides are equal. Double stroke means what? These two sides are equal. So later on, these little things will help you to solve the geometry questions very well. So we say that opposite sides are what beta? Equal. Opposite sides are equal, right? Third is what beta? All angles are at 90 degree, right? All angles are what beta? At 90 degree, right? Now let's talk about the diagonals. What do you mean by diagonals are equal in this? Diagonals are equal. Fifth part, diagonals just bisect each other. Like diagonals are equal. Diagonal bisect each other. That's it. Each other. It means what? If you're going to draw the diagonal, this and this, right? AC and BD are diagonal, and this point is O. So beta AO is equals to OC. OD is equals to what? Beta OB or not? Yes or no? As they're equal, so it means what? If they're dividing into half, they will be what? Equal or not? So this is equals to what? AO is equals to OC is equals to OB is equals to OD. As we have seen in the square, I wrote it over here that AC is perpendicular to BD also, but here they are not perpendicular. Here they just bisect each other, means they are equal. That's it. So this is a rectangle. Now let's talk about a rhombus. Beta, have you seen the fishing nets or not? Fishing nets and There are many symbols like you eat kaju katli, and there are many symbols like this, like made over here in your like day-to-day life. All these sides are equal, right? So this is what a rhombus, right? Basically, what is a rhombus? It says that if two adjacent sides of the parallelogram are equal, then we say this is a what? Basically, see, this side is parallel to what? This side, and this side is parallel to what? This side. So this is what a rhombus, right? So basically, its definition is what? If two adjacent sides of parallelogram are equal, then it is called a rhombus, right? A rhombus. It's called if two adjacent sides of a parallelogram are equal, like let us suppose if this is a parallelogram, right? So we have learned about in a parallelogram that opposite sides are equal, right? So if I say beta this side is equals to this side, then this side will be equals to this side. Automatically beta this will be all equal, so this becomes a rhombus, right? Rhombus in a fishing net, rhombus in like many of the figures you have seen, right? So fishing net is like on many of the signboards which you see that this is the shape they make, right? And every sides are equal, right? All sides are equal. So this is basically a rhombus, but this is not a square. Like if all sides are equal but all angles are what, beta 90-degree, then it is a what? A square. So let's go on the properties. Let me draw a rhombus. This is A, B, C, D. Okay, so what are the properties, beta? Let's go proper T's, right? So what is the first property? Is that opposite sides are what, beta? Parallel. Opposite sides are parallel. Second is that all sides are equal. Yeah, this side is parallel to this side, and all sides are equal, right? So this, and this. All sides are means what? All sides are what? Equal. All sides are equal. Opposite angles are equal, beta. Here all angles are not equal. Opposite angles are equal. Yeah. Fourth is what, beta? Diagonals are not equal. Right. Fifth is what? If you're going to draw the diagonal, let me change the color. If you're going to change the diagonal over here, this is a diagonal and this one is diagonal. So as I said that the diagonal over here, they bisect, but they bisect perpendicular to each other. So we say that these will be what, beta? Equal. So this is equals to this and this side is equals to this side, right? So we say that diagonal bisect each other at 90-degree. That is, AO is equals to OC and OB is equals to what, beta? OD, and AC is perpendicular to what, beta? BD. AC is perpendicular to what? BD. So these are the properties. So let's discuss a little bit, a quick revision. So basically we have learned about the parallelogram, square, rectangle, rhombus, and yeah, square, rectangle, rhombus. So we have learned about the four figures. So all the figures are basically the parallelogram. So let's talk about in which two figures that opposite sides are equal. Opposite sides are only equal in what, beta? Parallelogram and in rectangle. All sides are equal. All sides are equal only in what, beta? Rhombus and in square. If I say opposite angles are equal, so it is equal only in what, beta? Parallelogram and in rhombus, right? If I say all angles are equal, then it is what? A rectangle and it is a square. Now let's talk about the diagonal. Diagonals are equal. Diagonals are only equal in rectangle and square. Diagonals are unequal in what beta? Parallelogram and in rhombus, right? So in which figure the diagonal bisect each other at 90 degree? They bisect, diagonal bisect in every figure rhombus, and it will be a what beta square. So these are the some small properties that you should be keeping in your mind, and you should be knowing the difference between all the four figures very fast. Okay. Now coming to what do you mean by trapezoid, right? Trapezoid. Here, just a second. Okay. What is a rhombus? It is a quadrilateral in which one pair, like you see that in the figure itself, that it has only one pair of the. See, somebody said trapezoid. Trapezoid is like the UK, right? We follow US, right? US terminologies. We say trapezium. We say what better? Trapezium. We follow the UK English, so that's we say trapezium, and UK follow trapezoid. So the both are the same, right? They are the synonyms for each other. In some of the questions, they ask you as a trapezoid, and it is a basically trapezium. So it is basically, it is a quadrilateral. It is a quadrilateral. That's it. It is a quadrilateral. Yeah, in which one pair, that's any one pair of opposite sides is parallel, is called trapezium. And you will be surprised that we'll be teaching you same properties, same thing in the class grade 8. Yeah, there is a chapter name that is understanding quadrilateral, and we'll be teaching you again this is stuff. So what we prefer student to please memorize and please do this stuff very nicely, because this is going to help you a lot, right? Okay. Okay, so here we see this over here in the given figure. We see this AD is what? Parallel to what? BC? Yes or no? We say AD is parallel to BC. And like we say, if the two lines are parallel, so let's talk about the properties. If I want to talk about the properties, so it does not have so many properties. So I'll just say about one properties. So let us suppose if this is a like a trapezium. Yes or no? Is this a trapezium? So if these two sides are parallel, how many angles will be made? Like angle 1, angle 2, angle 3. So angle 1, 2, 3, 4. So the angles on the parallel side and the angles on the parallel side. So we say that these angles on the same side. So we say angle 1 plus angle 2 is equals to what? 180 degree. And angle 2 plus angle 3 is equals to what beta? 180 degree. So can I give you the question? Like if this is a trapezium, right? This is a trapezium, and I'll just make a different type of trapezium. Just a second. Okay, just see. Yeah, this side is parallel to this side, and I said that this angle is 80 degree. Find x, and this angle is equals to what beta? 100 degree, right? Not 100. I'll write some other angle. Just a second. Yeah. And this angle is 60 degree. Find y, right? So I said find x and find y, right? Find x and find y. So see over here, as I said that this can be written as what? These two are what? Parallel lines. So can I say this as angle 1 and this as angle 2 or not? Right? So can I say that angle 1 plus angle 2 is equals to what? 180 degree. So this is equals to what? 80 plus angle 2 is equals to 180 degree. So angle 2 will be what? Beta 100 degree. 180 minus 100, it will be what? Angle 2 will be what? 180 degree, like 100 degrees. And let's talk about this. This is what? Parallel side. So this is angle 3 and this is what? Angle 4. So if this is 60 degree, 180 minus 60 degree will be how much better? 120 degree. That is angle y will be what? This is angle, or I can say that x is equals to what? 100 degree, right or not? And 180 degree. So y is equals to how much? 120 degree. That's it. Right? So never go on the figure the way we made, because we have not made the figure on the scale. So go on the like the definitions very carefully, right? Now let's coming to what are the kites? Kites you have seen like people playing with the kites and all, right? So if you see a kite is generally what? these two adjacent sides are equal and these two adjacent sides are equal. So this is basically a quadrilateral in which these two adjacent sides are equal and these two adjacent sides are equal, right? So let's talk. It is a quadrilateral, right? It is a quadrilateral, special type of quadrilateral. And kites, I think so many, everyone has seen a kite, right? And many have used like for playing the kites, right? So it is a quadrilateral. It is a quadrilateral in which, I'll write this in point, in which first two pairs of consecutive sides are equal. Consecutive sides are equal, right or not? So these two are what beta consecutive. This and this can be equal, but depending like two pairs like this. Let us suppose you're making this and this equal, this and this equal. So yes, this is again a kite. Let us suppose I made a figure like this, and like this, and I said that this and this and this are equal. Is this a kite? Yes, this is again a kite because see, if you see that the two pairs of the consecutive sides are equal, so yes, it is a kite, right? Okay. Um, okay. Second is what? Uh, non-vertex angle, that is non-vertex angles are equal. Yeah. So you see that non-vertex means what? Like this and this is meeting like this side, right? Okay. So this is the vertex over here, these common side, and this is a common vertex for like BC and BD. But this is what a non-common vertex, right or not? So this one and this one is what? With a non-common vertex. Yes or no? Like your non-vertex side, your non-common vertex of these two sides, right? So they're equal. And third is what, beta? The diagonals are perpendicular, right? The diagonals are not equal. We say the diagonals are not equal. Diagonals are not equal. And fourth is what? Diagonals are perpendicular. That's it. They don't bisect. They're perpendicular, right? Perpendicular. Right? So let us suppose I made the kite, right? This side is equals to this side and this side is equals to this side. So these diagonals are what, beta? Perpendicular to each other, right? Coming to the next slide. Okay, now let's do the true and false. Okay. Each angle of a rectangle is a right angle. Yes, it's true, right? The opposite sides of the rectangles are of equal in length. Yes, yes, it's true again. Okay, the diagonals of the square are perpendicular to one another. Yes, they are perpendicular to one another. All sides of the rhombuses are of equal length. This is again true, right? Okay, all sides of the parallelogram are of equal length. No, only opposite sides are equal. So it is what, beta? False, right? The opposite sides of a trapezium are parallel. Yes, opposite sides of a trapezium, not opposite, only one pair of his opposite sides are parallel. So it is false, right? It says it's talking about false because the opposite sides are not parallel. Only one pair of the opposite sides are parallel, right? Coming to what is a polygon. Polygon is basically any closed figure made up of the three or more line segment is known as what, beta? Polygon, right? So we have learned about, like, you should be knowing the name after it. So when it has three sides, right? So polygon means what? If you see the polygon, okay. So if you see that, that is first thing. That is, a polygon has same number of the line segment and the same number of the angles. If there are three sides, then it will have three angles. If it has four sides, it will have four angles. If it has five sides, it will have five angles, right? So we say that a polygon has the same number of angles as it has sides, right? So let's do. If it has three sides, then we say this as what, beta? Triangle, right? If it has having the four side, we say this as what, beta? Quadrilateral. We just did right now, quadrilateral, right? Now, if it has having the five sides, right? It has what? Three sides. Yeah. It have what? Four sides. Yeah. When it have what 5 sides, we say this as what beta? Penta. Penta means what 5 and gon means what beta? 4. Like if I say penta, gon. So penta means what 5 and gon means what side. So similarly, polygon means what? If you're going to break the word poly and gon means what? So poly means what beta? Many and gon means what? It is a closed figure made up of the line segment with many sides, right? Now, this is having a what beta? This is what? A 6 side. This is having what beta? 6 side. So it is called beta what? Hexagon, right? Now, this is having what? 7 side. And this is called beta heptagon or septagon. Somebody says heptagon, somebody says septagon. So I'll write heptagon. Hepta means what? 7. Now see, this is having the 8 sides, yes or no? So we say this as 8 sides. And this is called as what beta? Octagon, right? Now, coming to this is having 9 sides like 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is having what beta? 9 sides. So this is the side as what? Nanogon, right? Nanogon, right? And this is having the 10 sides. We say this as decagon. Decagon. 10 sides means decagon. So we generally memorize till 10 sides and that is okay with us. Okay. Later on, like till 10 sides and later on like for 11 sides, for 15 sides, we say it's a polygon with the 15 sides side, like a polygon with 12 sides. 12 sides we say that dodecagon, right? 20 sides we say icosagon, right? 20 sides, I'll just write this for you. 12 sides, these are the some names which is generally being asked. So we say for 12 sides dodeca, like dodecagon. And for 20 sides we say this as isopogon, right? Isopogon, right? Mm, yeah. Let me get the spelling correct. Mm, yeah, it's icosagon, right? That's the spelling mistake I was thinking. There's some spelling mistake I did. It's ico, it's not iso, it's icosagon, right? Okay, that's the spelling mistake I was thinking. It's it's icosagon, right? And this is 12 decagon, right? Okay. Now, I think so this is clear. Now, coming to the three-dimensional figure. Three-dimensional figure means what? These anything which is like having till now we have done the figures which have only like length and the breadth, like on the sheet of paper. Everything we have drawn on a sheet of a paper on a plane surface. Now, what happened when you start giving the height? That is known as what? With a three-dimensional figure. Now, let us suppose if you take let me just get this. Can you see this? I think so. I'll just stop sharing my this thing. Okay, just see over here. Let us suppose if I take the sheet over here, like this is a single sheet, right? This is what? A two-dimensional figure, right or not? This is a two-dimensional figure. But what I did, I took just like 10, 15 sheets with me, right? Can you see this? Can you see this? A 10, 15 sheet, the height has been increased or not, right? There is an increment of the height. So you have the length, you have the breadth, and then there will be an height. So the books which you use, the geometry box which you use, the entire laptop which you use is what? A three-dimensional figure. The phone which you use, like let us suppose this is my phone. So this is what? A three-dimensional figure, right? So anything which you use is basically that is a three-dimensional figure, or like the bed, that is a bed in which you like sleep, it's what again like a cuboid, right? Okay, so if it is a box bed, then it is a what? A cuboid, right? So basically we have a cuboid and a rectangle and squares and cubes all over us, right? So you will see that many figures which we come across, we don't know what the names are, but we say the names, but we should know what it is actually, right? And later on we'll be learning the properties more, and here this time we'll be learning what are the names and everything. And then later on in class 7th and 8th grade, then you will be learning your like what are the properties, and like you'll be finding the surface area and volume, everything you'll be doing it, right? Okay, so let me share my screen. Okay. So this is what a three-dimensional figure, right? Three-dimensional figure has basically the length, breadth, and the height, right? Okay, so okay, so let's study some of the like special. Let me just see. Okay, so these are the three-dimensional figures which you have in your day-to-day. Okay, okay. So you see like a book which you use. This is the figure, right? So you see that if you take a book, like any book which you have in front of you will have how many pages. Let's take an example of my phone, right? So you see that this is one side, right? This is the one side, right? And you see that this is the one side of it, this is the other side of it, right? And this is the one side of it, and this is the other side of it, right? So you see that this figure is what a generally a cuboid, right? So cuboid has been mean what are the flat surface, the total flat surface is called beta the faces, right? The flat surface is called the faces, and there you see that I'll give you an example by just showing you this thing. Wait a minute. Let us suppose like two faces that you're going to join, right? This is the way you're going to join. This is a very big figure. Yeah, wait a minute, I'll take a small one, right? ah Yeah, let us suppose you're going to join these two figures, right? This is the one surface and this is the other face, right? You're going to join it. So when you join, the point of intersection, like the point of intersection of the two surfaces will be a what? This is called an edge. This is called an edge, right? Let us suppose when I'm going to open this, right? Yes or no? I'm going to open this. So can you see this? This is the edge. This is the edge. This one is again the edge or not, right? And this one again is the edge, right? What is a vertex? Vertex means what? When the two or more than three planes intersect. So can I say this is a plane one, this is a plane two, this is a plane three, this is a plane four. So this is these two planes are intersecting over here. So this point is called as what beta? Vertex, right? Vertex means what? When the three or more planes meet at each other. So that is called as like yeah. So this is one surface, right? And let us suppose this is the other surface. So you're going to join this. This will be a what? The joining point will be a what? A edge. This is called an edge. So when you take any book in front of you, let me just take some book in front of me. Let's suppose I have this, right? So see over here, this is what? Your edge. This is what? Your surfaces. Yeah. This is called beta what? Surfaces or surfaces face. This is like one phase, then it have two phase, then it have three phase, then it have four phase. It have what? Five phase, and this have six phases. Like how many edges it will have? Just count the edges. So this will have how many edges? Like one edge over here, then two edge over here, right? And this is turning the book. So this is what? Three edge. This is the fourth edge, right? Uh, this is this fifth. This one is sixth, right? And this one is the seventh. This one is the eighth. And then you will have your heights or not. So 9, 10, 11, and 12. Yes, so you will have 12 edges for the cuboid, right? And how many vertices you will have? So vertices will be how much, beta? The vertices will be how much? So you just see the vertices. So this is like one vertex, right? You see this is my one vertex. This is my second vertex. Then below you have the third vertex, and here you have the fourth vertex going at the back, right? So here you will have one, two, three, and four. So you will have in total of how many vertices, beta? Eight vertices you will have for a cuboid, right? Yes or no? So you just see in the figure also. Okay. So I'll write down the definitions for you. What is the faces? That is each side of cuboid. Let's talk. This is what a cuboid, right? This is called as what with a cuboid, right? So cuboid, or we say this as a cube, right? So each uh, instead of writing this in a very way, um, I'll write in a more better way. Just a second. That is the flat. That is each side of the three-dimensional figure is a flat surface. That is basically that is a flat surface that is any flat surface, right? The any flat surface of a figure, that is flat surface, we say this, flat surface of three-dimensional figure, like we say that for three-dimensional figure, we have to talk about the flat surface, not the curved surface, right? Three-dimensional figure, right? Then we have edges, right? What we say, this is edges. When like two faces, this is like face one and this is like face two. Here they are meeting, right? So this is what your edge. Here it is also they are meeting, so this is again an edge. Like two faces meet in a line is called edge, right? And then we have a vertex where three edges, right? Where we say three edges meet at a point is called a vertex, right? Now we have like see many figures. Now over here you see that it will have a see, this is an ice cream cone, right? So will it have a flat surfaces? It will not have any flat surfaces. Yes, this will have a curved surface. Yes, so this is what an ice cream cone, and this will not have any flat surfaces. It will have just one vertex, right? Yeah, so this is basically what a cone. Yeah, this is a what a cube. Yeah, we say this as what cuboid. This is called as what cylinder. Yeah, so we see this cylinder. This one is what a curved surface. Yes, this is what called curved surface, and the top and the top will be what a circle or not. So this will be a what a flat surface, flat surface above and the surface surface, right? Similarly, you have seen the ice cream and everything, right? Now let's coming to, this is a what a sphere, like which the ball which you use, this is called as what bit a sphere. So basically it does not have any flat surfaces, so it does not have any faces. We give the dimension like any flat surface, right? So basically we say that a sphere have no surfaces. Over here this is what a bit of pyramid, right? This is what called as pyramid, right? So I'll write down this, what is a pyramid. um hmm. See over here, you have seen this figure over here. Okay, I'll write down the definition for pyramid. Pyramid is nothing. You can take the base of any number, right? You see that the side faces are what triangle. You take the different triangles and you just join at the tip of the point, and the base can be a what any type of the polygon. So basically, a pyramid is a solid in which the vertices of one faces called the bases are joined by the edges to the other vertex called the common vertex or the apex, and the base is a polygon and the all other faces. I'll just write it down for you, then I'll explain this. A pyramid is a solid in which the vertices of one face, the vertices of one face called base are joined by edges to one other vertex called common vertex or apex. Full stop. The base is a polygon and all other faces are triangular. right? So you can see this is like, you think like ma'am has written a very big thing. It's easy. Have you seen the pyramid of Giza? So you see that the side faces are what, beta? Triangle. So it says that it is a solid figure in which the vertices of like vertices of one face is called the bases. Like you see that every vertices, it's like you take and you take the other triangle, and this is called beta what? Apex, right? This is called apex, and you join all the triangles to make it like the three-dimensional figure. The base, here you are taking the base like a triangle, then it is said to be a triangular pyramid. If you're taking the base as a square, then we say that it's a square pyramid. If you're taking the base as a pentagon, then it is said to be what, beta? Pentagonal pyramid, right? Okay, let's do what is the shape of your instrument box. Your instrument box is generally a what? The shape of what? A cuboid? Yes or no? Right? A brick. Brick is again what? A cuboid? Yes or no? A matchbox is again what? A cuboid? Yes. A road roller is what? A generally what? A cylinder? Yes or no? A sweet laddu is what? Your sweet laddu is in the shape of what? Sphere? Yes or no? So this is the figures you see. So generally it is a what? A cuboid, 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 cylinder, and sphere, right? Okay. It says that a figure is said to be a regular. It is an illustration. A figure is said to be a regular if all sides are equal in length and angles are equal in measure. Can you identify the regular quadrilateral? So this is easy, right? So it says that what is a regular polygon? It means what? It says that all sides are equal, right? Yes, all sides are equal. Okay, and the sum of the angle of a quadrilateral is 360 degrees. So each angle, if you're going to divide 360 divided by 4, so each angle will be what, beta? 90. So which is this quadrilateral form we have just learned about? So this quadrilateral is what, beta? Square, right? This is a square, right? In which all sides and all angles are what? Equal, right? Okay, now coming to a diagonal is a line segment that joins any two vertices of a polygon, and that is not a side of the polygon, right? Draw the rough sketch of a pentagon and draw its like diagonal, right? So let's draw a pentagon like this: 1, 2, 3, and then this is 4, right? So let's draw the pentagon. I think so I showed you this figure. So let's do it again. D and E. So let's talk about with the, so draw up a sketch of pentagon and draw its diagonal, right? So what will be its diagonal? Let's take some different colors and start doing it. So let's take the vertex A. So this will be your diagonal, right? And this will be your diagonal, right? So write it down. This is AC and AD, right? Let's take a different color. Um, Yeah, take the vertex B. Okay, so vertex B, you will have BE and BD, right? We have already done this beta. So this will be what? BD and BE, right? Now let's take the vertex C. Let's take the vertex C. With the vertex C, you will have AC already made. Now there is only one thing left, that is AE, right? So this will be what? CE. Now take the vertex D. You have both the diagonals made. Take the vertex E. You have made both the diagonal mates. So these are what beta? Your diagonals, right? Okay. Can you see this figure? Right. Now, find the number of the diagonals in the heptagon, right? So this is going to be a trick question. So what you have to do, you have to draw a heptagon, right? So let's draw an heptagon. 1, 2, 3, 4, 5, 6, and then 7. Try to join like this. 1, 2, 3, 4, 5, 6, and then this is 7. I'm very poor at drawing, but try to understand my feeling it. Yeah. So take this as A, B, C, D, E, F, and G. Let's draw its diagonal, right? So let's take different colors and try making it. Okay. Okay. Take the vertex A, right? So it will be what? AF. It will be what? AE, right? It will be what? AD, and it will be what? AC. Yes or no? Right? So it have what? Four diagonals, that is AF, AE, AE, AD, and AC, right? Yes or no? That you don't have to join the adjacent sides, right? You have to take the other vertex, right? So let's take the other color. Let's take the vertex B, right? So it will be what? AC and ABC, and BA will be what? Its adjacent side. So it will be what? 1. This will be your 2. this is going to be 3, and this is going to be what, 4, right or not? So you write it down over here. That is AG, no, BG, right? Then BF, then you have BE, and you have it in BD, right? Okay. Now let's do the other. Okay, let's take the other in color. Okay, let's take purple color. Let's take the vertex C. So BC, CB, and CD are what? It's side. So let's join with CA. CA is already joined. Now join CG. CG is not joined. So CG, right? Then CF is not joined. So let's draw CF, right? CF. And then join CE, right? This is what beta CE. And then CD is what already gone. So we have got the 3. Now let's take the vertex D, right? So if you're going to take the vertex D, red we have already taken, so let's take different color. Let's take orange. Okay, let's take the vertex D. So vertex D, that is DC and DE are what beta? It's diagonals, yes or no? It's sides, adjacent sides. So it will be what? DB is already joined, right? Now DA is already joined. Now DG is not joined, so we'll be joining DG, right? It will be what beta? DG, right? Now DF is also not joined, so we are going to join DF, right? Join DF, right? And D is adjacent side. So we have got this much. Now let's going to the like next color. Let's take the this hot pink. Yeah, this looks same. Let's take some pink color. Okay. Um, let's take this. Now let's take the vertex E. With the vertex E, you will see that CEF and ED are what? Your adjacent sides. So we have CE already written, EB already written, EA already written, EG not written. So we'll be joining EG, right? So this will be what beta? EG, right? EF is a side. Now let's take the side F. I think so we have got almost all of it. See, F say FG and FE are what your sides. So FA already written, FB already written, FC already written, FD already written. No need to worry about it. Now let's go on the G. G may, if you see that GA and GF are what beta? It's adjacent sides. So you have to join GB already joined, GC already joined, GD already joined, and GE already joined. So how many diagonals does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it have what beta? 14 diagonals it have. So actually there is a formula for it. Actually you can see that is a formula for diagonal. I'll write it for you. Formula for diagonal is what beta? N minus 3 by 2, right? Where n is equals to what beta? Number of sides, right? Number of sides. So this is a longer one, and from here you can get the answer in the shorter way. I'll give you one example for this. Let us suppose what is like number of diagonal. I'm asking you, that is number of diagonals, as we did number of diagonals in pentagon. We have already done that pentagon and hexagon, right? And hexagon. Second is what beta? Hexagon. Hexagon. So let's do for pentagon. Like first is what beta? Pentagon. So pentagon has how many sides? Yeah, see this. So this will be what beta? Pentagon. Pentagon. So pentagon have how many sides? It has how many sides? Side is equals to what? 5, which is equals to n. The formula is equals to what beta? The formula is equals to what? N into n minus 3 by 2, right? So this is equals to what? 5 into 5 minus 3 by 2. So this is equals to 5 into 2 divided by 2. 2 cancels, so 5 diagonals it have, right? So we have already done it. So let's do for hexagon. Second is what beta? Hexagon. So hexagon will be having how much? So sides will be having how much? Side is equals to what? 6, which is equals to n. So what is the formula for diagonal? Diagonal is equals to what? N into n minus 3 by 2, which is equals to what? 6 into 6 minus 3 by 2, which is equals to 6 into 3 by 2, this 2 and 2, 3 cancel, so which is having a 9, right? So it will have 9 diagonals. You can just do make a figure as we made it for the septagon. You make the figure and just see that this is true for septagon also. Yeah, heptagon, that is heptagon. N is equals to what, beta? 7. So diagonals will be how much? Just check by the formula also if this is working or not. So 7 into 7 minus 3 by 2, which is equals to what? 7 into 4 by 2. This and 2 cancels. So 7 into 2 is equals to how much, beta? 14. That's it. So you got the answer or not? Right? So this is the way you can just get the answer. So this formula you can use for your competitive point of purpose, and otherwise for the examination purpose, when your teacher tells you, you have to draw the figures and see how it is made. So I have taught you in both the ways, and I think so we have done with this chapter. And if you have any doubt, please ask your respective class teacher in the class, and you can ask this doubt on the forum. And thank you, class. Thank you so much for this class. And we have done with the elementary shapes, understanding elementary shapes. So please keep on practicing your Ask IT module and your school textbook. Please, those things are very important. So first, always practice your school book, and then you go on your Ask IT module. Thank you so much, class. So we will meet you soon. Bye bye, Vijay.